Good morning to all of you. In previous session, we have seen how difference equations are useful over convolution to identify the response of IR systems, right? As well as we have discussed the difference between recursive and non-recursive system. We can efficiently compute the output in case of recursive system compared to the non-recursive systems, right? So in today's session we will be discussing LTI systems characterized by constant coefficient difference equations, right? So LTI systems are described by an input output relation called difference equation with constant coefficients. So systems described by constant coefficient linear difference equations are subclass of recursive and non-recursive systems. Right? So you can describe the recursive and non-recursive systems by using the constant coefficient difference equations. Right? So just for example, if I'm considering one input-output equation, okay. So if I'm considering this first order difference equation, y of n is equals to small a into y of n minus 1 plus x of n. Okay, so it is I can call it as what, first order first order is called as first order difference equation. Okay, so if I'm considering this input output relationship described by the first order difference equation, so as well as in the recursive and non-recursive system, so uh, this system is basically recursive because y of n depends on the past output. Okay, so therefore it is a recursive system, right? So it is a recursive system whose output is described, input output relationship is described by the first order difference equation, where this small a is a constant, right? If I want to represent this system in block diagram form, so input applied here is x of n, right? So it is getting added with the feedback output. Okay, so this y of n can be delayed here, right? So you will get y of n minus 1. Okay, so this y of n is feedback to the system through delay elements. So output of this delay element is y of n minus 1. Then I can multiply it with this constant. Okay, so I have to use a constant multiplier here, right? So it will be multiplied with small a, and this addition will be performed here through this adder. Okay, so here input is a into y of n minus 1, right? So which is getting added in x of n, right? So this system described by this first order difference equation has a constant coefficient small a, okay, which is independent of time, whereas the system that we have seen in previous session, the equation for the recursive system that we had obtained from its non-recursive version, okay, that was n upon n plus 1 y of n minus 1, okay, plus what was that, 1 upon n plus 1 x of n. Okay, so this equation we have seen in previous session. So this equation has the variable coefficient. Okay, so I can also call it as variant coefficients. Okay, so it has variable coefficients because n upon n plus 1 depends on this time variables small n. So these coefficients are dependent on time. Okay, both these coefficients are dependent on time, but here in this case this coefficient is a constant coefficient, right? This example we have seen in earlier session. Okay, so this was the again a recursive system. Okay, but this recursive system is described by using variant coefficient difference equation. Okay, so variant coefficient difference equation. Okay, so if I'm considering the same equation here, that is y of n is equals to the constant coefficient difference equation, y of n is equals to a y of n minus 1 plus x of n. Okay, so we are moreover interested in LTI systems described or characterized by the constant coefficient difference equations. Okay, so if I am identifying the values of this output response, okay, for n greater than or equals to 0. So just for example, if I am substituting n is equals to 0, so what equation I will get? So it will be y of 0 is equals to a y of minus 1 plus x of 0, right? If I'm substituting n is equals to 0. If I'm substituting n is equals to 1, because I'm taking n greater than or equals to 0, because there is no negative time as such, right? So we can consider time starting with 0 and it is getting incremented by 1. Okay, so if I'm substituting n is equals to 1 in this case, so I will get y of 1 is equals to a y of, so 1 minus 1 will be 0, right, plus x of 1, right? So I substituted n is equals to 1 in this equation, right? So what is y of 0? Y of 0 is this value. Okay, so I can substitute this value in place of y of 0. So I can get this equation, okay, after substitution, right, in place of y of 0, if I'm substituting this complete equation, so this a will get multiplied with this equation, so it will be a square y of minus 1, right, plus a into x of 0, right, plus this term will be as it is, that is x of 1. Okay, so this is the final equation. Similarly, I can identify it for what? Y of 2, right? So if I'm identifying it for y of 2, so it will be a y of 2 minus 1, so it will be y of 1, right? Plus x of 2, correct? Again, in place of y of 1, I can substitute this value, right? So if I'm substituting this value, again it will get multiplied with a here, so I'll get a cube y of n, sorry, y of minus 1, right, plus a square x of 0 plus a x of 1 plus this x of 2 will be as it is. Okay, so this is the equation for what? Y of 2. So in similar manner, if I want to identify the equation for y of n, that means the final response of the system. Okay, this is the input output relationship, but now I am trying to identify the response of system for various values of n. So for n is equals to 0, this is the response, right? For n is equals to 1, this will be the response, right? For n is equals to 2, this will be the response. But if I want to identify the final response of the system, so here you can observe that depending on the value of n, the power of a is varying, right? So if it is n is equals to 1, the power of a is square, right? If n is equals to 2, the power of a is cube. So it is greater than, so that means it is this value plus 1. Okay, that is n plus 1 is there at the power of a. The first term contains y of minus 1, y of minus 1 everywhere, right? But this y of minus 1 is multiplied with this constant, that is a to the power n plus 1, right? A to the power n plus 1 plus, here you can see the same value is here, that is a square, here it is 1, so a to the power 1 is there, it is 0, so a to the power 0 is there, right? So what will be the value then? So it will be a to the power n x of 0, right? A to the power n x of 0 plus the power is getting decreased, okay, it is decrementing, right? So first one is a square, then a to the power 0, so a to the power n, next will be a to the power n minus 1 into x of 1 plus a to the power n minus 2 into x of 2. So if you observe, the last term here is x of 2 because n is equals to 2. Here last term is x of 1 because n is equals to 1 here. Here last term is x of 0. So here this n value we have taken, so the last term here will be x of n, right? But before x of n, there will be obviously a into x of n minus 1 will be there, right? Plus last term will be x of n, right? So this is how we are identifying the final response for n. Okay, so I can again write down this equation in more compact way. Okay, as this indicates the initial condition y of minus 1 that we have seen in the previous session, right? So basically time is starting with n is equals to 0, so y of minus 1 is the initial condition, and generally we consider that initial condition y of minus 1 is equals to 0. Okay, if it is not explicitly specified in the system, then okay, so this output term will be keeping as it is, so a to the power n plus 1 into y of minus 1 will be as it is, then plus so these terms comprising the input sample, that is x of 0, x of 1, x of 2 up to x of n. Okay, so n is greater than or equals to 0 we are taking, so therefore it is starting with 0, so x of 0, x of 1, x of 2 up to x of n. So this can be again more compactly written by using summation. Okay, so I can write summation k is equals to what I can write here, so k is equals to 0 to small n. Okay, so because the last value of k can be taken as here is n, right? Or you can say that a to the power n is there, so last value I can take n, and the first value is a to the power 0 is there, so a to the power 0 is 0, a to the power 0 is 1. Okay, so its coefficient here is 1. Okay, so I can represent it as a to the power k, right, into, I can specify it as a to the power k into x of what I can specify, n minus k, right? So again this is for what, n greater than or equals to 0. So if I'm substituting these values here, so if I'm substituting last value of k, so it will be a to the power n x of n minus n, so it will be x of 0, so a to the power n x of 0 will be there, right? Similarly, if I'm substituting previous value, so previous value will be n minus 1, so it will be a to the power n minus 1 into x of n minus, so minus 1. Okay, so this minus minus will be plus, so it will be x of 1 simply, n minus n will be 0, right? So likewise you can identify. So this is the more compact representation of this output response, okay, for this constant coefficient first order uh, system, okay, described by the given first order difference equation, right? So I'll write once again this equation, final equation here. So what is this equation? Y of n is equals to, what was that, a to the power n plus 1 into y of minus 1, right? A to the power n plus 1 into y of minus 1 plus summation k is equals to 0 to n a to the power k x of n minus k, right? X of n minus k for n greater than or equals to 0. Okay, so the response y of n of the system as given by this equation, so its right hand side of above equation consists of two parts. Okay, so the first part, which contains the term y of minus 1 is the result of the initial condition y of minus 1 of the system. So this can be considered as this y of 1 minus 1 is considered as initial condition. Okay, while second part, the second part is the response of the system to the input signal x of n. Okay, so this second part comprises the uh, response of system to input x of n. So this complete part describes the response of the system for the applied input signal, right? So First part is the response to initial condition, right? And second part is the response of system described by the initial condition, and the second part is the response of the system to input signal x of n. Okay, so if we are considering if the system is initially relaxed, okay, if system is initially relaxed, then its initial condition, that is y of minus 1, is equals to 0. Okay, if system is initially relaxed. Okay, if system is initially relaxed, that means its memory doesn't contain anything, and you can consider the initial condition y of minus 1 is equals to 0. So a recursive system is relaxed if it starts with 0 initial condition. Okay, because memory of the system describes in some sense its state basically, right? So we say that the system is at 0 state and its corresponding output is called 0 state response or the forced response. Okay, so when we are considering this initial condition y of minus 1 is equals to 0 and system is initially relaxed, then its response is called as what? 0 state. Okay, that is initial state, 0 initial state response. Okay, more specifically it is referred as the 0 state response, or it is also called as the forced response. Okay, so it is called as 0 state response or forced response when we are considering the system as it is initially relaxed, that is the initial condition y of minus 1 is equals to 0, and the 0 state response or forced response is denoted as y z s of n. Okay, y in suffix z s of n, that is 0 state response. Okay, so if I'm considering the above system, okay, the system described by the equation that were identified here. Okay, so if I'm considering this same system, in this system if I'm considering y of minus 1 is equals to 0, then this system's 0 state response will be given as what? Because this term will be 0. In that case, if I'm considering initial state is equals to 0 of the system, then the 0 state response will be simply summation k is equals to 0 to n a to the power k x of n minus k. Okay, so this will be the 0 state response of the given system. Okay, so that we are assumed there, right? So this is what 0 state response is, right? So in similar manner, if if system is not relaxed initially, okay, so if we are considering second condition, here we are defined the 0 state response, okay, or forced response when we are considering the initial state of this system is equals to 0, then 0 state response will be like this for this system. Okay, in given equation, response equation, we are substituting all initial state of the system is equals to 0, then only the 0 state response depends on the input signal x of n. Okay, it doesn't depend on the past outputs. Okay, so the second condition if we are considering that again I will write the same equation here, okay, that we have obtained. Okay, that is nothing but y of n is equals to a to the power, what is that, n plus 1 y of minus 1 e to the power n plus 1 y of minus 1 plus summation k is equals to 0 to n e to the power k x of n minus k, again for n greater than or equals to 0. Okay, so initially we have seen it for relaxed system, that is when initial state is equals to 0, then its response is referred as the 0 state response. Okay, now suppose that the system is initially non-relaxed. Okay, so here we are considering system is non-relaxed. Okay, So system is initially non-relaxed, that is y of minus 1 is not equals to 0. Okay, and if we are considering and the input x of n is equals to 0 for all small n. Okay, that means we are not applying any input to the given system. Okay, but system is non-relaxed, right? That means minus 1 is not equals to 0 in this condition. Okay, in this equation, right? It may happen that your response equation also comprises the initial condition y of minus 1, y of minus 2, y of minus 3, and so on. But in this example, only one initial condition is there, that is y of minus 1. Right? So if we are considering the system as non-relaxed system, that is y of minus 1 is not equals to 0, but if we are not applying any input and considering input is equals to 0 for all n, okay, then the output of such system is called as zero input response. Okay, why we are calling it as zero input response? Because we are applying zero input here, right? So it will be referred as what? Zero input response, or it is also called as natural response of the system. Okay, natural response of the system, or it is also called as free response. Okay, why natural response? Because we are not applying anything to the system. The response depends on only initial condition of the system. Okay, or it is also called as free response or zero input response, and this response is denoted as y z I of n. Okay, y z I of n. So this y z I of n, if I'm considering again this equation, so in this case it will be simply a to the power n plus 1 y of minus 1. Okay, because y of minus 1 is not 0 in this case because system is non-relaxed, but we are considering input 0 here, so this second term will be 0 simply. Okay, so this zero input response will be given by this equation, that is zero input response is equals to a to the power n plus 1 of minus 1. Okay, so here what we can conclude, so the total response, okay, the total response of the system or the LTI system, okay, the system can be expressed as okay, so it can be expressed as, right, so there are two terms. First term is for what? uh, First set of term comprises zero input response, second term comprises zero state response here, right? So this can be taken as what? Total response y of n as y z I of n plus y z s of n. Okay, that is zero input response plus zero state response of the system, right? So this is the equation for total response of the system, that is zero input response plus zero state response. So uh, it comprises two parts. The total response of the system comprises two parts, that is zero input response and zero state response. Okay, so the general form for such an equation, okay, is given as we have already seen this particularly. Okay, so that is y of n is equals to minus summation k is equals to 1 to capital N, right, ak y of n minus k, right? So first part comprising all previous outputs, right, with constant coefficients here, right, plus second term comprises all inputs, that is present and past inputs, that is k is equals to 0 to m bk x of n minus k, right? So if I'm trying if I'm trying to identify if I'm trying to substitute the values of k here, so this can be written as y of n is equals to what minus, if I'm substituting these values, so it will be a1 y of n minus 1, right, plus a2 y of n minus 2, right, plus and so on, plus a n y of n minus n, right. So this first set of terms contains only past outputs, right, multiplied with some constant coefficients, right. Why negative sign has been taken here? So it is the generalized form of the difference equation. Okay, so this is the generalized form of difference equation. So this can be considered as what? General form of difference equation, right. So used to describe the response of any recursive system, right, or even it can be used to describe the non-recursive system. In case of non-recursive system, this term will be 0, right. So why we are taking it as negative sign? Because generally output present at the left hand side of the equation. Okay, so plus, if I'm substituting the values of k in this input, it will be b0, right, x of n, right, so it will be b0 x of n, okay, plus b1 x of n minus 1, okay, plus and so on, plus bm x of n minus m. Okay, so the second set of terms contains the present input and the past input values, right. So if I'm just transferring this term on the left hand side, we already seen this. Okay, so y of n plus what will be the equation? K is equals to 1 to n, so a k y of n minus k is equals to summation k is equals to 0 to m bk x of n minus k, right. And if I want to take this term inside the summation, so I can start it as what? Instead of k is equals to 1, I can take it as k is equals to 0 to n a k y of n minus k, right, summation k 0 to m bk x of n minus k. Okay, so if I'm substituting k is equals to 0, so it will be a0 y of n minus 0 will be y of n, but here a0 is 1, its constant coefficient is 1 here, so I can assume it as a0 is equals to 1 in this case. Okay, so basically this equation, okay, this particular equation is the generalized form of the difference equation used to describe any recursive or non-recursive system. Okay, so basically this capital N indicates here the order of the system. Okay, whether it is the first order, second order, third order, fourth order system, it depends on the value of capital N. Okay, whatever system that we have considered here. Okay, so here it is the first order system, right. So here you can say it is as the nth order system, right. So this is how we can describe any LTI system by using the constant coefficient difference equation. Okay, so in next session we'll be discussing how to solve the linear constant coefficient difference equations to identify the response of given system. Okay, so the response of given system can be identified by solving the given difference equation. That difference equation represents the input output characteristics of the given LTI system. Okay, that we'll be discussing in next session, right. So in today's session we have seen how the first order difference equation can be considered, right, how variant coefficient difference equation can be represented, how constant coefficient difference equation can be represented, how to identify the total response of the system. So total response of the system comprises zero state response and zero input response. Zero input response is also called as natural response or free response. Zero state response is also called as forced response. The total response of the system is nothing but the combination of zero input response and the zero state response. Okay, so it comprises two parts. The total response of the system comprises two parts, that is zero input response and the zero state response. Okay, so in next session we will be looking at how to solve the given linear constant coefficient difference equation to identify the response of the given system. It may be first order system, it may be second order system, or it may be third order system. Okay, so thank you for joining this session.